Okay, so we're going to be talking about distributions today. That's our first topic for the review, which we'll spend several days on. So I haven't really decided if I want to make one video for several days or how we'll quite do this, but we'll figure it out. So socks. So we're going to talk about that. Hopefully it's something we're fairly good at. So shape, outlier, center, spread. Now, one thing to kind of keep in mind is if they just talk about general, like they ask you to describe data, talk about center and spread in terms of general. Just say the center is here. You don't really need to differentiate between the mean and the median, because that leaves you guys open for a mistake. Sometimes you guys will talk about the mean when you don't have the right to talk about the mean because you don't have the information, or vice versa. So really kind of think about keeping it more general. So shape, hopefully we know we have symmetric. Now, we also talked about that as approximately normal, but symmetric's a perfectly fine way to go. So we have skewed right and left. And we also have things like bimodal, which hopefully so bimodal is a hump. Skewed left means the tail is on the left. Skewed right means the tail is on the right. And symmetric should be roughly. And then we also have something called uniform, which is just everything is the same. All right, outliers, be very careful about talking about outliers. It's okay to refer generally. It looks like this is an outlier. But if we have data, especially if we're talking about, they give us information about the median, we need to use our formula. We'll go over that in a moment. Center, hopefully we know, we'll talk about that. Largely, we're talking about mean and median. But again, if they're just asking for a general description, just talk about the center. Mean and median. We'll talk about those in a moment. Spread, generally, we talk about IQR, range, and standard deviations. And again, all this stuff is talking about individual data, not sampling. This is an individual sample. They give us some data about one sample. They do a sample of 100 people. They give us that data. They don't say what another sample would look like. Okay, so let's real quick address. So guys, if you are asked to describe data and you do not write out socks, stop. Write out socks and then colon and then write a sentence and then like make sure you write it out. Even if there are no outliers, just write no outliers. But be in the habit of writing out socks. Some of you guys are still trying to freeform paragraphs about this and you're screwing it up. Guys, English class, that's where you want to be creative about your writing. In math and technical writing, you want to be concise and you want the people that are looking at your data to know where to find stuff. This is not just true about a math class and about passing a test. This is how you should write memos for businesses, science reports. There is not a place for creativity. We are writing things concisely and right and easy to find. Do not make people look for your answer within your pose. This should be easier than this. So guys, write out socks. The other thing is be careful to use comparative words. More often than not, they don't just ask you to describe data, they ask you to compare data, guys. So compare data is about the same. Greater than, less than. So it might be like A has more outliers than B. Neither of them have outliers. The shape on this is more skewed than the shape on this. The center is larger on this than the center on this. The spread is bigger than the spread. You don't even need to give numbers. You're comparing which one's bigger, which one's smaller. That's all you're doing. Make sure you do not just sit out there and list the mean is 4 and the mean is 8. Well, that's great. That's not comparative. That's just information on each. Again, I don't care that the mean's 4 and 8. I care that the mean is bigger or smaller. So again, guys, please make sure if they're asking you to compare to use comparative words. In fact, it should make your life easier because you're not worrying about individual data points. You're just saying bigger or smaller. That's it. All right. Now, a couple other things. Outlier. So when we talked about outliers, it's okay. Like if you're just given data and you see a dot out here, that's fine. But if they give you information about the median, the 5-number summary. So guys, if they give you the 5-number summary, well, what's the 5-number summary? It's the min. It's the Q1. It's the median. It's the Q3. And it's the max. 1, 2, 3, 4, 5. So if they give you this information and they ask about shape, center, and spread, well, there's a couple things that you really got to keep in mind. So for starters, the median, the IQR, the interquartile range. So basically what we're saying is if this is a box and whisker plot, we have something like this, right? So this is min, Q1, median, Q3, max. And if there's any dots, those are your outliers, right? Well, how do we find an outlier? Well, if they give me this information, we find an outlier by doing this formula. It is our Q1 minus 1.5 times the IQR. And Q3 plus. So you go to the bottom and you go 1.5 boxes out. Plus, and you go to the top 1.5 boxes out. So in order to be an outlier, you have to be smaller than this number or bigger than these. These are our limits. So if there are no numbers smaller than this, there's no outlier. If there is a number, it's an outlier. There are no numbers bigger than this. There are no outliers. If there are, they're outliers. That's the gist of it. So these are limits for outliers. But so another key point that we reiterated quite a bit in this unit, compare mean to median. So can I find out the shape if I know the mean and the median? Well, the answer is yes. So if the median is bigger than the mean, that means an outlier. The mean is bigger than the median. So the mean is sensitive to outliers. Means it's more affected than the median. So the median is not sensitive. So if I have a big, huge outlier, it's really going to mess with my mean, but it's barely going to move my median. So what that means is if the mean is pulled out to the right, it means there's an outlier to the right. So that means it's skewed to the right. If the mean is smaller than the median, it means it got pulled to the left. And that means that there's an outlier to the left. And if they're the same, we can assume that it's probably symmetric. All right, so if I were to give 5-number summary in the mean and the median, I should have enough to go ahead and do a full analysis of SOCs, come up with outliers, not just say there is an outlier, tell you what numbers are outliers. And then I should be able to tell you the shape, whether it's skewed right or skewed left. All right, so that is honestly largely what we covered in this. So in the review packet, you're just going to be talking and making comparative language about mean, median, mode. You're going to be finding outliers. You're going to be talking about data, talking about spread, and all that fun stuff. So I'm going to stop there, and then we'll hopefully talk about some of the problems in class. All right, thank you.